reliable, we said that it does error control. Reliability and error control go hand in hand. Do you remember these three differences? Congestion control, flow control, and error control. Do we remember this? Everyone? We are heading towards end of the semester and course. So we better know that by now, and if it is not clear, then we might need to think of some alternative ways to cope up with that. So Prince, can you please tell me what is flow control? You can unmute yourself and answer as well. Prince, what is flow? Yes, that is true, Prince. Based on the receiver's capacity, if we are tuning our transmitter's capacity, then we say that is flow control. In error control, we ensure data integrity. Whatever data we are sending, if that data is correctly received by the receiver, then fine. If it is not, then we will take the remedial actions to do it. Then we say we do the error control. Now let us talk about one of the major features of TCP, which is congestion control. Can you tell me what is congestion control? What do we do in congestion control? Not how do we do it, but what do we do in congestion control? Anyone? Controlling entry of the data, when, why? Is it like controlling flow of the transmitter, Abhi? Yes. When there are too many packets in the subnet, performance degrades. That is true. At the sender side, both of you are right. Both of you are right. But I would still like a more wholesome answer. Can anyone tell me that? Both of you are right. Can anyone just rephrase it for me? Unmute yourself and tell me, please. Anyone? Okay. So, in flow control, we are talking about receiver's capacity and then transmitter is sending data according to that. While in case of congestion control, we have to take into account capacity of the routers as well. So in the layman's term, we can say that congestion is equivalent to traffic. Whenever the routers which are there on the way, if they are getting more data, then they can forward, then they'll be using queue. But whenever incoming data is more than capacity of queue plus outgoing data, I repeat, whenever any router is getting data at higher speed, then it can forward and store together. Then it will have no other alternative than to drop the data. Data will be discarded. This is due to congestion. So when we say we are doing congestion control, we try to minimize impact of this. That is what we try to do. Are we together so far? In error control, we worry about the correctness of the data. In flow control, we ensure that data is sent according to receiver's capacity. Like if we are talking about TCP, then flow control is explicit in TCP. We have talked about two types, explicit and implicit. In explicit, receiver tells directly that what it will be doing. In implicit, receiver doesn't tell you, but based on the acknowledgement arrival rate, you try to figure out that whether receiver is doing fine, and then you send data according to that. Like if you are sending data and if you got acknowledgement after 10 seconds, again you're getting acknowledgement after 10 seconds, 10 seconds. But if now you're getting acknowledgement after 11 seconds or 12 seconds, then you try to suspect that, okay, receiver might be busy or there is something wrong. That is why the arrival time in the acknowledgement has higher, and then you try to figure out the flow. If you do that, then that is implicit flow control. However, that is never going to be more accurate. So in case of TCP, we want to have the utmost sophistication, so it is explicit. And how do we ensure flow control? Through which parameter? Dynamic buffer or window size. Yes, the parameter is window size. Your window size is declared periodically by the receiver. The buffer is dynamic and window size is reported to the transmitter, and transmitter sends data according to that. So now let us talk about congestion control. So let me show you something, and then say, feel free to ask me whenever you have any doubt in this topic. This is pretty interesting and important, both together. I'll show you one diagram here. Ideally, what we would like our network to be. See, there are two terminologies, good put and throughput. Okay, I'll tell you what throughput is. Throughput means how many bytes are sent successfully in a second or in unit time. That is throughput. Throughput is how many bytes are successfully received by the receiver in the unit time. Like if we are sending 10 packets and each packet is of 1000 bytes, then, and if that is sent in 1 second, they are delivered at the receiver, then we can say throughput is 10,000 bytes, because 10 packets and 1,000 bytes each. So 10,000 bytes per second, and bytes per second is the throughput's unit. Like it could be bits per second or packets per second, you can convert that. But the idea is this, how much data has been successfully delivered. Now good put, you will try to find out afterwards, not right now, afterwards. In the next class, you will remind me and tell me that what is difference between good put and throughput. They are pretty similar. They are measures of successfully sent data only. So anyway, let us say this is our capacity. The highest one, the dotted line here, is our capacity. So usually, what do we do? Like when we are going to start sending data. Okay, before that, I would like to very quickly remind sender's window. Have you heard this term, sender's window, before? Sender's window tells us that how much data can be sent without waiting for the acknowledgement. I mean, you have to send that and then wait for the acknowledgement. And then once receiver's window tells us that how much data you can send, sender's window tells us that what permission do we have to send data at the moment. So can you tell me what should be sender's window ideally? Like if we're talking about stop and wait protocol, then it is 1. But here we know that selective repeat sliding window protocol is adopted. And our receiver's capacity could be something which probably you are knowing here, right? Because receiver has reported you. So what should be your sender's window? Should your sender's window be same as a receiver's window or some fixed size or something else? How do we send our data? What should be your sender's window? Same as receiver's window, or rather I would say, shouldn't it be minimum of the network capacity in receiver's window? Because see, if most of the time, memory isn't that memory isn't that difficult to allocate for a connection these days. So receiver will be telling you that you can send 10,000 bytes, but we are not sure whether our network can carry that, because most of the time, not always, again I repeat, not always, but most of the time receiver's window might not be a very critical parameter. It could be sometimes, but network capacity will be. When I say network capacity, that means what your network can carry. So if receiver tells you that it can get 10,000 bytes per second, but is your network capable of carrying that? Because you are not the only user. The bandwidth is being shared by many users and they are dynamic. Currently, there might be 5 users. After some time, you might be the only one. After some time, there might be 50 users and so on. So if your network can carry only 5,000 bytes, and if your sender's window is same as receiver's window, which is 10,000 bytes, then 5,000 bytes might be delivered and 5,000 bytes will be randomly dropped by the network. So if I knew that network's capacity is 5,000 bytes, then I'll assign my sender's window as 5,000. I'm sure I'm making some sense to you, right? So network capacity is actually, okay, now let me ask you a question. Can we have exact idea of the network capacity at the moment, that what is the current network capacity? Can we know that? No, we cannot, right? Because when I say network, like receiver is just one entity, one system, and there is one parameter there, memory. Receiver's window will be reported to us. But when I say network capacity, then I'm talking about minimum of the current capacity of router 1, router 2, router 3, up to router n. That is what I mean by network, isn't it? And the bandwidth between that and the router's forwarding capacity. So that is not one unit who will tell us, like network is not going to tell us. If I tell you that what is your class, what is the capacity or what is the understanding rate of your class, something like that, then you are not going to answer me, like all of you are individual units. I'll have to estimate that based on posing some questions, by looking at your facial expressions, by your performance in the sessional exams and some other parameters. So I'll have to estimate that. I'll never have an accurate idea that what exactly is happening in your head. Similarly, network capacity at the best can be estimated. We will never have exact idea of the network capacity. So we estimate network capacity through a parameter which we call congestion window. Through congestion window, we try to estimate our network capacity. So I can say that whatever is the minimum of congestion window and receiver's window, that should be the sender's window. Whatever is minimum congestion window and the receiver's window, that will be my sender's window. So again, this is not universally always true, but most of the time, whatever is the value of congestion window, that will be the sender's window, because receiver's window is likely to be larger. But in case if receiver's window is 0, then you are not going to send any data. If receiver's window is lesser than congestion window, then you will be sending data only according to the receiver's window. However, in reality, in practical situation, congestion window will be the restricting parameter, not the receiver's window. Again, I would like to pause here and ask you whether are you with me? Okay, any girl? One of the girls? Are you following me? Okay, thank you, Palna. What about others? Anyone else? Okay, Hemangini, thank you, fine. So now be with me and tell me that when we start sending data, let us say we have just gone for 3-way handshaking, our connection has been established. Now, what should we do? When we are sending data, should we send data as per receiver's capacity and then see if our network can carry that, and if network cannot carry, then we will reduce it. That is one approach. That start from the maximum and then see if it is passed. If it is not, then we will see. The other approach is assume that network is heavily congested, start from the slow. If it is delivered, increase. If it is delivered, increase. If it is delivered, increase. These are two approaches. Should we start from the less value or should we start from the higher value when we are beginning the connection? What would you opt for? Priyank says he'll start with the small value. What about others? Oh, all of you are wise. That makes sense. Not to be greedy, but start from the smaller values. Or you are smart that you are taking hint from this. But if we are starting from the larger value, then what will happen? Like if network is already congested and if you are sending too much of data, then you are worsening the network situation, and it is not going to help anyone. More packets from the other will be dropped, and then they will again be starting from the larger one. Your packets will be dropped. Like if our network is already congested and we have to check the capacity of that, so we should be sending first one car. If it says yes, then send two cars. If they say yes, then increase slowly, rather than sending 50 cars and then see if they get through. So we should be starting slowly, and yes, there will be so many retransmissions if you start from the larger value, and data will be lost. You will have to send that again. Is all of these are consequences and not the good consequences. So we will certainly avoid that. We will be prudent and will be responsible. So initially, let us say when we begin, we send data slowly, and when we reach the capacity, network capacity, then ideally what should happen? Once we reach the network capacity, this should be the stable one. Okay. This is what, but this cannot be achieved in the real life. So desired response could be something like this. Gradually we increase and then we try to stable near the capacity of the network. But usually what happens that whenever there is congestion, this is the congestion spot, something like that. Like once you reach here, then you are going to reach to the network capacity. And if there is congestion, then whenever congestion episodes are taking place, then data will be dropped. When data is dropped, then our transmitter will be cautious that, oh, what I was sending is not getting through, so I should reduce the speed. You will have to retransmit the data, so new data will not be sent for a while. So your performance will be decreased. Whenever there is congestion, then performance will be decreased. And if there are single or scattered episodes of congestion, then that is okay. But whenever high level of congestion, high degree of congestion will be there, then congestion collapse will be there and performance might be drastically decreased. Anyway, so this is the network capacity and this is our desired response. If we can get something like this, we are very, very happy. If we can, somehow stabilize somewhere here, then we are happy. And sometimes there might be some glitches, that is also acceptable to us. But due to congestion, a network should not collapse. So that was the theoretical part and general common sense, and which we can already think about. Now, how TCP does this, I'll directly go to that part. So in TCP, this was congestion control in general, this was congestion control in general, which is applicable to TCP as well. Now in TCP, we start slowly. Slowly means just our congestion window value will be one maximum segment size. I'm not going to mention that afterwards. Currently, I'm doing it. Start slowly. Just send one segment, not one byte, one segment. Whatever is the maximum segment size decided by your connection from A to B. A will be sending one segment of that. If it is 1000 byte, it will be sending 1000. If B has decided to send to data at A at 2000 bytes, it will be sending 2000. I'm trying to intervene several concepts here. One is that MSS can be different in both the directions. TCP is a bidirectional protocol and both the parties do not need to send data at the same speed. They'll be sending data based on the maximum segment size as well as what the other party has declared in the window size. So anyway, initially congestion window will be 1. Then if it gets this acknowledgement, then it will be made 2. Then your congestion window will be made 2. If it gets 2 acknowledgements of both the segments, then it will be doubled. It will be 4. It gets 4 segments. They are delivered to the receiver, and if receiver sends you 4 acknowledgement, then you will be making it 8. Then if you get 8 acknowledgements, you will make it 16. if it gives you 16 acknowledgement, you are making it 32, you are making it 64, and so on. So we are starting slowly. We are starting with just one. But afterwards, we are increasing data exponentially. We are doubling that whenever you are getting the successful acknowledgements. This phase is known as slow start. This is known as exponential increase. So can you tell me up to what level should we double that? Is it wise to double forever? Like if your network has delivered 64 segments, is it okay to assume that it will be able to deliver 128 segments also? And if 128 segments are delivered, that is still okay. But will it be able to send 256 segments? And by chance, if it gets through 256 segment, then should you be sending 512 segments and so on? Initially doubling is justified and is reasonable. But after a value, if we keep doubling this, then we are sure to introduce congestion in the network. Like if one segment is of 1000 bytes, and if we are sending, if our network can carry 12,000 bytes, then we are saying that, okay, take 25,000 bytes. And by chance, if it goes through, then how reasonable it is to send 50,000 bytes. And if it goes through 50,000 bytes, and then if you are dumping, 1 lakh bytes, then you are going to cause the congestion sooner or later. So the point I'm trying to make is that for the smaller value of congestion window, we may double that. But after a point, we have to be cautious. We cannot keep doubling like this. Otherwise, certainly we are going to send more data than what your network can tackle. And that will result into congestion. That is why we have something called slow start threshold. So your data will be doubled only until it reaches slow start threshold. Once it has reached slow start threshold, then we are not going to double our congestion window, but we will enter into linear rise. We will be cautious now. Like let us say if we assume that our slow start threshold is 128. If we assume that our slow start threshold is 128, is it 128 bytes? When I say slow start threshold is 128, what is 128? Segments. Yes, 120. No, not bytes, segments. Or maximum segment size. 128 segments. So then we will be sending 128 segments, and when 128 segments are delivered, we will make it 129. You are increasing just by 1 then. And once you have sent 129 segments, if receiver gives you acknowledgement of 129 segments, you will make it 130. Once 130 is delivered, you will make it 132, then 133, and so on. In short, in linear rise, we are very cautious. Now we suspect that congestion may take place at any point of time. So we are just sending one more segment and try to see, is our network okay? If it is, we are again sending one more segment, and this is what we are going to do. Tell me if it is clear so far, or if you have any doubt, feel free to ask me. How many of you understood this concept? That sender's window should be minimum of congestion window and receiver's window. We don't know congestion window, so this is our process of estimating the network capacity or estimating the congestion window. We start slowly just by 1, then we double that, we keep doubling that until we reach the slow start threshold. Once the slow start threshold is reached, then we enter linear rise and congestion window value is increased by 1 after you get all the acknowledgements back. So tell me how many of you understood this? Because I would like to go, step by step. Okay. So now tell me, if we adapt this behavior, Ayush, like 131 segments were sent, then 132 segments, 133. So will we be able to increase very slowly, even in the linear rise forever? like 133, then 140, 141, 143, 150, 151, 152, 154, and so on. Always do you think we'll be able to increase it slowly, or there will be some point? No, of course not, right? At some point of time, we are going to exceed the network capacity, because please remember, network is a shared resource. This we are talking about just one connection. And one connection means from your computer, there might be 10 connections of TCP. This is just one connection from your computer to the receiver. There will be so many users, and each user might be having multiple connections. So everyone is probing the network, and everyone is trying to get the maximum benefit from this. So at some point of time, we are bound to have sending data together by all the users, which will be more than the capacity. So what will happen then? How will we come to know that, oh, now we should stop it? How will we come to know it? Tell me, how you will experience that at the sender? How will we experience that? Acknowledgement will not come. There is no support of negative acknowledgement in TCP. There are no negative acknowledgements in TCP. But acknowledgements will not come, and you will have a timeout. So in short, we can say that whenever we have a timeout, at that point of time, we have got to be cautious that I have sent this, but here acknowledgement has not come. And that is why there is something wrong. So whenever, okay, I'll first show you the diagram. This is what we have been talking about so far. That initially, these are on the y-axis, we have congestion window. We have started with 1. We have sent 1. When we have got acknowledgement, then we have sent 2. Then it was made 4. Then it was made 8. Then 16. And something. So here our slow start threshold for an example was set to 28. Then at 28 we have stopped. Then we made it 29, 30, and so on. And whenever there is a timeout, then we will know that, oh, now we should reduce the congestion window. So if acknowledgement does not come, then because we don't know degree of the congestion on the network, we'll assume the worst. We will assume that our network is highly congested. And what should we do? We should retransmit that. Of course, whenever there is a timeout, we should retransmit the data. And apart from that, now we have to reduce the flow so that our network will be relieved from the congestion. So because we don't have better information, your congestion window will be again set to, what do you say, 1. Whenever there is an episode of timeout, retransmission timeout, then your congestion window will be reset to 1. And your slow start threshold will be reinitialized with whatever was the recent congestion window by 2, and then congestion window will be 1. Like in this scenario, it was 40. Let us say in this scenario it was 38. Let us say it was 38 here. If it was 38, then here slow start threshold will be 18. Then it was 39. It was something like that, whatever. Half. Yes, it is halved. Whenever your timeout is taking place, at that point of time, slow start threshold is reinitialized by half of the congestion window. What was the latest congestion window by half? And your congestion window will be set to 1. So what we will do? Again, we will enter the rise. Like from 1, we will make it 2, 4, 8, 16. And once we reach the slow start threshold, then again we will enter in the linear rise. So this is slow start where we are exponentially increasing. And another value, another name of linear rise is congestion avoidance. Why are we entering in the linear rise phase? To avoid the congestion. So this is known as congestion avoidance. And whenever there is a congestion, then it will be doing this. And again, it will be reinitialized. It will keep probing this network until there is a timeout. Whenever there is a timeout, again your congestion window will be 1 and slow start threshold will be half of the congestion window. So this is how continuously we'll be progressing, and we will try to manage TCP congestion control. This is basic TCP congestion control which was introduced in early 80s. When the TCP was introduced, at that point of time, this congestion control mechanism was there. Then there have been some changes which we'll talk about. Yes, this process is infinite because our network, it will continuously throughout our congestion window value will be changing, and it has to change because our network is a dynamic usage. I mean, network is used by dynamic number of users. So if when you join the connection at that point of time, there were 5 users, then you might be sending data at this capacity. But after some time, if there are 15 users, then many of them are sending, congestion will be there. So you will be reducing, and everyone, if there are 3 connections who are experiencing RTO, they will reduce that. So others will get chance, you will try to send data, and at some point of time, this will happen. So this will go throughout until your connection lasts. Is this okay so far? Then I would like to draw your attention to something pretty interesting. Feel free to ask me if you have any doubts. We can discuss that. If you have any suggestions, doubts, etc. But if it is clear so far, then I would like to tell you something, and then again I'll take the questions. Threshold, initial threshold will be decided by the operating system. Subsequent threshold will be based on what was the congestion window at the time of timeout. And ideally, your slow start threshold, even if it is larger, then let us say if it is unrealistically larger, then the constraining parameter will be the receiver's window. Your sender's window, no, it will not go to 1. First, we will, like here, I don't understand. Can you unmute yourself, Chanel, and tell me what question you are asking? Are you suggesting that because at the time of timeout, we are resetting our congestion window to 1? Okay, no problem, Chanel. So whenever there is a timeout, then we are resetting our congestion window to 1. That is why slow start threshold also will be 1. That is what you are saying? Or are you... No, threshold is not threshold by 2. Threshold is congestion window by 2. See, please read carefully. Slow start threshold is congestion window by 2. No problem, that is okay. We are learning here. Can we go to threshold instead of 1 value of congestion window? Yes, Priyank, I'll take these questions. I was expecting something like this, and nice that you have thought about it early. But please hold the horses for just 2-3 minutes, and then I'll talk about that. So, is this fine so far? Have you observed this behavior in the real life? Have you observed this? Have you experienced this? Like when you try to download a file initially, then you will it will tell you that it will take 1 hour. Then within 1 minute, it will tell you that no, it will take 50 minutes. Then it will tell you that no, it will take 30 minutes. And after some time, it will tell that it will take 15 minutes. And then it will slowly say, from 15, it will say that now, okay, 15, 14, 13, 15, 12, something minutes. Because initially, our congestion window value was lower. So it will try to estimate somewhere here that, okay, if I'm keep sending data at 8 segments per second, then this is the time I'll be, not second. Can you tell me the unit? I'm avoiding using that term. On the x-axis, what is the unit? This 1, 2, 4, 6, 8. What are this? No, they are not segments. They are not seconds. No. Think about that. We sent the congestion window worth data. We wait until we get the acknowledgements. Once we get the acknowledgements, we double it. Once we get the acknowledgements, we double it, and so on. So each of this, yes, Kevin, well done. That is RTT. So here it is RTT. So after each round trip time, your connection says that I'm going to send 8 segments per RTT. Then this much time I'll be consuming. Then after some time, it will realize that no. Actually, I'll be able to send data at 24. So I should be requiring much lesser time. So very quickly, drastically, unrealistically, it will be changing. but it enters in the linear rise or congestion avoidance, then it is stabilized. So slowly, gradually your file will be downloaded and it will be slowly decreasing. How many of you observed this? That when you try to download very large file, then initially it says unrealistic, and then afterwards, yes, you observed this, right? And then we have reached like 10 minutes will be left to download a movie. And then after some time, it might say that no, I'll be taking now 13 minutes, not 10 minutes. That might be due to congestion because now your congestion window has reduced. So again, it is, somewhere here, and then it is giving you the idea. So what we are talking about is actually implemented in the real life as well, and you have experienced this as well. So now I'm going to the Priyank's question, that we said that whenever there is timeout, that means our network is congested. And if our network is congested, then because we don't know degree of the congestion, we are sending the smaller amount of data. So we are resetting to 1. That if our network is congested, then let us not overburden it with higher amount of data, and we are sending 1. But it would make sense to go to the previous value, not the previous value, but half of that. Like even if you are in slow start, then we have sent 24 only if 12 had been delivered. We have never come to this stage without getting acknowledgements of that. So if you either you have doubled it or you have just sent one more segment. So if you are not getting acknowledgements now, is it very wise and advisable to drastically reduce it to 1? No, because that will affect our behavior, right? Our efficiency. Because see, again we will have to probe that. So many RTTs will be vested to know the actual network capacity. So in the not recent, I mean it has also been 2 decades now, but it was afterwards recommended that whenever there is a RTO, then your congestion window and slow start threshold, both of them should be half of the previous congestion window, because your network has carried half of that. That is why you come to this stage by doubling it. So if it cannot send it, then let us go for the half. Still, if there is congestion and it cannot do it, then again it will be halved and so on. But we are not going to just cut it to 1. So this is what is actually implemented. This is what, not exactly this, but any algorithm which will be doing something similar to this and never this. Are you with me? Okay. So are you finding it interesting? Yes, I'm glad. So now there is a question which you should ask me. And if you don't, I'll ask you that question. Does it sound very rational and logical to you right now, or still there is some glitch which you think there is a scope of improvement? Okay, then let's see. So if we look at the value of congestion window roughly, it would be something like this. It will try to increase and then it will be halved, then again increase half of that, this value half, and so on. Yes, Chanel, I was expecting this question as well. Like, why to half that rather than not going to the previous value? Can we just shift to the previous lower value rather than halving it? That is what you are asking. So for that, each transmitter has to know that which state it was in. Was it in slow start or was it in linear rise? If we can maintain this information, then probably we can do it. But doesn't matter in whichever state is it. Making it half is very easy, and it is the most conservative and safe approach. Like even if it was in slow start, it could have been done. And one of the topics of my PhD was this only. One of the topics which I have tried to address is this. Like, it has been bugging me from the beginning. Like, why to half it? So, if it is a slow start, we should half it. But if it is congestion avoidance, we should try to find out some moderate value. So, we would not say just go to one. Like, we cannot say that I have sent just one more packet, so I'll be withdrawing just one more packet only, because we will try to be generous in that scenario, and we'll try to reduce the flow so that your network is already congested and it can be relieved from the congestion. But something like that has to be done. Is it possible at the timeout network capacity is reached instead of congestion? But if even if you're reaching the network capacity, Priyank, then you will introduce congestion. You can never fully utilize network capacity because there are multiple flows. Like there are probably 15 parallel connections and all of them are sending. So if network capacity is reached at this point of time, then next point of time all 15 will be sending one more, and some of them might be in the slow start. The new connection might be in the slow start. They'll be doubling that. And then there will be congestion. It is possible to store it. Of course, it is possible to store it, and accordingly it can be done. Yes, it can be done. But here the concept is TCP was bound to, I'll answer this after something else. So again, let me remind you that if we don't have an acknowledgement at hand, is it always because of congestion? That is what we are assuming right now, right? Whenever we don't have an acknowledgement, that means we have RTO, retransmission timeout, and then we assume that our network is congested. We have to be responsible and send less data. TCP has been robust and our network has survived over the years. If you just look at the TCP design from early 80s to this, it has been closely 40 years, but there has been hardly some changes, minor changes, like it was first one and then it is halved, but the basic design was same. And that is because of responsible characteristics of TCP, that it was bound to design in an environment where everyone thinks about everyone else, and robustness, efficiency, performance, everything is taken care of, not just the greedy approach of performance. But it has to relieve network from the congestion whenever there is congestion, so that other connections don't suffer and everyone behaves like this, then our network will survive. That is a bit philosophical as well, if you think about that. Anyway, so I'm going to the question again. Whenever there is a timeout, is it always because of congestion? No. What is the other possibility? It can be because of congestion, or it can be because of, see, if acknowledgement is dropped, then also that is because of congestion only. Because why would acknowledgement be dropped? Because your router was congested. Okay. Connection loss can be a possibility, but I was expecting something else which you are well aware of. Size means? Maximum segment size is decided by our network. That size are you implying, Devansh? I'm unable to find out. No. So maximum segment size is already decided, and we are never sending more than what your receiver tells us. Receiver's capacity. Here we are assuming that receiver's capacity is larger. Then based on the congestion window, your transmitter will be sending data. But ideally and theoretically and actually also practically, we are doing that only. Minimum of the receiver's capacity and the network capacity we are doing. So all this under the assumption that if our receiver's capacity allows you, if your receiver does not allow you, then we send as per receivers only. Then congestion window will be a second parameter. Have I addressed it, or you were asking something else? Okay. Come on, everyone. If you don't get an acknowledgement, then that could be because of see, when you say segment drop, that means that is congestion only. Segment was lost because of congestion. Acknowledgement is dropped because of congestion. Connection loss is something else. That is true. Crash, yes. If it is crash, that is also okay. Capacity is reduced. Yes. So if capacity is reduced, that means that is congestion only. Yes, Prince. Thank you. Because your data might be incorrect. While your data was traveling, there was some error. And at the receiver, checksum didn't match. So if checksum did not match, then no acknowledgement will be sent. So here, if you don't get an acknowledgement, that is not necessarily 100% of time because of congestion. It could be because of congestion or error. And I would use term corruption. Both of this will lead to absence of acknowledgement. Isn't it? So initially, when our TCP was designed in early 80s, at that point of time, wired links were used. Wireless links were barely used at that point of time. Most of the links were wired links. And on the wired link, we know that errors are not much of an issue. Whatever data we are sending, it will be reliably delivered. But now, as heterogeneous networks are used and many links are wireless links, and we know that characteristic of wireless links is to be error prone. There will be more errors in the wireless links. Errors as in corruption. 0 bit might be very easily triggered to 1 because of the environmental factors or other factors, interference and all that. So even if 1 bit changes, your segment will be erroneous, or it will be corrupted, or it will be incorrect, and no acknowledgement will be received. So in this scenario, whenever you don't get an acknowledgement, that is not very wise to assume that that is due to congestion and reduce it. But again, it is not wise to assume that it will be corruption and keep sending at the same speed. What if it was congestion? So we will assume the worst, that whenever it happens, it is due to congestion and congestion window will be reduced. And originally it was very justified as well, because there were only wired links which were prominent in the networks. But now, due to increase in the wireless links, just to not have some acknowledgements and assume that it is because of congestion and reducing flow will hamper the performance. It will decrease the performance. Because I think you understand by now that if it is corruption, response of the transmitter should be different, and if it is congestion, response of transmitter should be different. Like we are assuming that you have a surefire way of knowing whether it is congestion or corruption. Then what will you do in case of congestion, and what will you do in case of corruption? Sitting at the transmitter, what should we do? If it is congestion, what should we do? If it is congestion, like you have sent some 50 segments, and now we have realized that it is congestion. Then if it is congestion, then retransmit and reduce the window size. Very good, both of you, and many of you might be thinking the same thing. And once we know that it is corruption, not the congestion, by chance if you are 100% sure that it is corruption, then do not reduce the congestion window. Flow reduction is not required, only retransmission is required. But because we don't know better, the default approach is taken. So this was another topic which I have addressed in my thesis, and many researchers have been working on this. They try to somehow differentiate or discriminate the cause of the timeout, cause of the acknowledgement absence. And if we can, decide that based on some parameters or some ways, then we can accordingly send our data and our performance will be improved. And when we say our performance will be improved, that means everyone's performance will be improved, because unnecessarily when you are reducing the flow, then you are stretching the connection. For the longer duration, you are going to be active on that connection. Otherwise, earlier you would be done, and someone else who is not active alive will be, when that fellow joins, he'll be able to have the maximum share of the network. So We are not doing this just to improve efficiency or performance of this connection, but on the whole it will be better, and then will be lesser fluctuation, especially, I repeat, especially when wireless links are used. If you know that your network is just of the wired links, then this is perfectly fine. But if it is mixture of wired and wireless, or in case of only wireless, just to assume that always congestion is dropping the data, and hence we should be halving the congestion window, reducing the flow, might not be the best approach to take. So please ask me if you have any doubts so far. So I'll advise every one of you to read this, because this topic is pretty close to my heart. So you better pay attention to this. This might be having some more weightage in the examination as well. Okay, I'm just kidding. It might be having more weightage because it is very important as well. From the gate perspective, even like the speed which you are going to get on the internet depends on this. So please think about, can you do something else? But not right now. First, you will read this from the textbook. Read congestion control from textbook Tenenbaum. There will be 2-3 pages, and on next Wednesday we'll talk about this. Will you be reading it, please? Thank you. Everyone, please try to read these 3 pages so that you will have clarity over this topic, and subsequent is dependent on this. So if it is clear, you will be able to understand that as well, and you might come up with some better ideas or some better queries which might be challenging, and we would be talking about that. So with this, I'll end the class. Thank you.